Other topic I'm gonna explain is Doppler effect, and this is a physical phenomenon that occurs when there is a relative motion between a wave of source and an observer. It describes the change in the observer frequency or wavelength of a wave, such as sound, light, or electromagnetic waves, due to the motion of the source, the observer, or both. Now I'm gonna explain the Doppler effect. And our problem is a pedestrian is walking toward a bicyclist who is ringing a bell at a constant frequency. The pedestrian walks at a speed of 1.5 meter per second and hears of the bell at a frequency of 430 hertz. The actual frequency of the bell is 400 hertz. If the speed of the sound in air is 343 meter per second, what is the speed of the bicyclist? Assume the bicyclist is approaching the pedestrian head on. So we're gonna do the diagram, taking on count that the pedestrian is our source and the bell is our observer. So the exercise is telling us the pedestrian is moving forward, so it's moving to this way, and the bell is basically stationary but going this way because they are forward. So as when the object is moving this way, it's gonna be negative, and when the object is moving this way, it's gonna be positive. So the formula we would use would be the total frequency times plus the speed of the observer and speed minus the speed of the source, cause how I told you, when it moves this way is negative, so the source is negative and the observer is positive. So this exercise is telling us to find the velocity of the source. So our final formula would be the speed minus the frequency times speed plus VO over the total frequency. Our data is our observer velocity is 1.5 meter per second. Our total velocity is its speed is 343. Our frequency is 430 hertz, and it's 400 hertz. So we're gonna use our formula, and then we're gonna substitute our values. So it will be 343 minus 400 times 343 plus 1.5 over 430, and then we put this on our calculator, and our answer would be 22.53 meter per second, and this would be our source velocity.